Grace and peace to you all, and welcome back to my YouTube channel. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Okay, so today's question: differentiate the following from first principle. So we have y is equal to x minus 1 over x squared minus 1. Okay, so before we use first principle, before we differentiate from first principle, you can see that this fraction can be simplified. So first thing, let us simplify the fraction. Okay, so we have y is equal to x minus 1 over this denominator, x squared minus 1, can be factorized. Yeah, so can be factorized by difference of two squares, since we know that x squared is a perfect square and 1 is a perfect square, and we have a minus there. Okay, so this will give us the square root of x squared is x, and the square root of 1 is 1. So this will give us x plus 1, that is the product of x plus 1 and x minus 1. That is a factorization by difference of two squares. Okay, so we can see that we have a common factor here. We have x minus 1 on the numerator, and we have this x minus 1 on the denominator, so we can divide out. Okay, so this is equal to x minus 1. In x minus 1 you get 1, then in this x minus 1 also 1. So we are going to have 1 over x plus 1. So in short, we are saying y is equal to 1 over x plus 1. Okay, so we are going to differentiate y is equal to 1 over x plus 1 from first principle. Okay, so the formula for differentiation from first principle is given as, say, this is the derivative of y with respect to x. So dy dx is equal to, so we are going to have limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so from this it's just a matter of substituting where there is x from our initial question here. Where there is x, we are going to put x plus h. Okay, and this f of x is the initial question, that is y is equal to 1 over x plus 1. Okay, so dy dx is equal to limit as h approaches 0 of, so the first one we are going to put x plus h where there is x. So we have 1 over, where there is x, we have x plus h, then plus 1, and this should be minus f of x. F of x is the initial problem, which is 1 over x plus 1. Okay, then this whole thing is divided by h, or in short is multiplied by 1 over h. Okay, so we are going to expand this. We say dy dx is equal to limit as h approaches 0 of, so this 1 over h will multiply through what is in the brackets here. So we say 1 over h multiplied by this, we are going to have 1 over So it's just h multiplied by x, h multiplied by h, and h multiplied by 1. Same with this. So h multiplied by x, you get xh, plus h multiplied by h, you get h squared, plus h multiplied by 1, you get h. Then minus h multiplied by x, this is 1 over, so you have xh, plus this is 1 multiplied by h, you get h. Okay, so we have a fraction here, 1 over xh plus h squared plus h, then minus 1 over xh plus h. So the simplest and easiest way of working out fractions is just to multiply. You multiply the denominators. You multiply the denominators, and you cross multiply. Okay, so we say dy dx is equal to limit as h approaches 0 of, so you multiply these two. You multiply these two, you get. So when you multiply these two, you get this xh. We multiply everything here, and plus h will also multiply everything here. So you say xh multiplied by xh, you get xh x squared h squared. Xh multiplied by h squared, you get plus xh cubed. Xh multiplied by h, you get plus xh squared. Okay, then plus h multiplied by xh, you get plus xh squared. H multiplied by h squared, you get plus h cubed. H multiplied by h, you get h squared. Okay, then you cross multiply. 1 multiplied by xh plus h, you just get xh plus h. Then you're going to have minus. So 1 multiplied by xh plus h squared plus h, you get the same thing. So there's minus here, so you put them in brackets. You say xh plus h squared plus h. Okay, so it's just a matter of simplifying those terms. So dy dx is equal to limit as h approaches 0 of, so we expand this, we're going to have xh plus h, then minus multiplied by xh, you get minus xh, then minus multiplied by plus h squared, you get minus h squared, minus multiplied by plus h, you get minus h, and this whole thing over. So here we can collect the like terms here. So okay, h squared, x squared, h squared will be maintained. You have x squared, h squared. Okay, then h cubed, okay, to be maintained as it is, x h cubed. And this one x h squared, there's also x h squared, so we are going to have plus 2 x h squared, then plus we have h cubed plus h squared. Okay, so if you look at this on the numerator, first dy dx is equal to limit as h approaches 0 of xh and this minus xh will cancel out, because xh minus xh, that is just 0. Okay, then we have plus h and minus h. This is also cancelled out, so we are going to remain with minus h squared. So we have minus h squared on top, and over. Now if you look at the denominator here, on the denominator here we can see there is the highest common factor of h squared, so we can divide out h squared. Okay, so we divide out h squared here, so we are going to have h squared, then in brackets we are going to have, so x squared, h squared divided by h squared, we are going to have x squared plus x h cubed divided by x squared, you get x h squared plus 2xh squared divided by h squared, you get 2x plus h cubed divided by h squared, you get h plus h squared divided by h squared, you get 1, so plus 1. Okay, so we can see that on the numerator there is h squared, and on the denominator here we have h squared, so h squared is common, so we can divide out h squared. Okay, so we are going to have dy dx is equal to limit as h approaches 0 of, so h squared and h squared is 1, and there 1, so we are going to have negative 1, that is minus 1, over, we have x squared plus x h squared plus 2x plus h plus 1. Okay, so dy dx is equal to, so here we are saying limit is as h approaches what? 0. So where there is h, we are going to put a 0. So dy dx is equal to minus 1 over x squared plus, this is h is 0, so 0 multiplied by x will be 0, plus we have 2x, this is h is approaching 0, so plus 0, then plus 1. Okay, so this is equal to, we have minus 1 over, this is x squared, 0 is nothing, so we have plus 2x plus 1. So that is the final answer. So we have found the derivative. So this is the derivative for the derivative of y with respect to x from first principles. So you get it's minus 1 over x squared plus 2x plus 1. So this was the question. It was y is equal to x minus 1 over x squared minus 1. So from first principle, that is our answer. That is minus 1 over x squared plus 2x plus 1. Thank you so much for your time.